Hello friends, in this video we are going to look at a very fundamental data structure concept. Learning data structure and algorithms is very important if you wish to become a successful engineer or a programmer. In this video we will talk about linked list. We will explore what is a linked list, some operations we can perform on a linked list, and advantages and disadvantages of using a linked list over an array. So let us begin by understanding what is a linked list. So imagine you have some data which you wish to store in your memory. And this data can be represented in the form of a node. So this is called a node, right? This is called a node. And a node consists of two important components. The data, let's say I represent a number out here, and this is a pointer. This is a pointer to the next node. So in this example that I'm drawing on the screen, let us say we have 4 nodes. So I have another node with a value 13, and this 13 is again connected to a third node with a value 14, and the 14 is connected to 15, right? So a node consists of two important things: a data value and a pointer to the next node. And at the beginning of the first node there is another important pointer which is called the head of the node. So a head always points to the very first element in the linked list, and the very last node, that is also called the tail of the node, always points to a null value. So we wish to now implement this from scratch in Python. So how can we do this? So let us now begin by defining a node class. So we will begin by creating a node class. So you can open an editor and implement a node class. Now in the constructor of the node class we need two important entities. We need the data value and the pointer. So I will define the constructor out here, and a node will take a value. So every node is represented by some value. So I can initialize the data to the value that I have passed in the constructor, and whenever a new node is created, initially the pointer which I am representing by next will always remain null. Now this is just this one part. So this is just this one entity which is called a node. Now linked list is composed of many such nodes, and there are a lot of operations we can perform. We can insert an element at the beginning of the list. We can insert an element at the end of the list. We can delete an element or a node from the list. We can traverse through the list, and we can of course print and also search for an element in the list. So we will try to implement all of these functionalities in our class. So I will begin by defining a class called linked list. Linked list. And the constructor of the linked list will have a head pointer. So initially self.head is null. Now I will implement the very first functionality, that is the ability. We want to have the option to add a new node at the front of the list. So there are two possible scenarios when we are adding a node in the list. Let us say the list is empty. In that case, we create a node. We will create a new node, and the head pointer will point to this node. And in the second scenario, let's say you already have a node. So there is already a node out here, and there is a head pointer, and you wish to insert another node in front of this node. So what will you do? You will create this node, and this node will point to the previous node which was at the front of the list, and the head pointer now will point to this newly created node. So this is what we wish to achieve out here, right? This is which we wish to, yeah. So we will implement this. So we will define a function called insert front. That is, we are trying to insert a node at in the front of the list, and this function will take a node with a specific value. So this node will be of class node, so it will actually be of class of type node. So we begin by first checking if the list is empty or not. How can we do this? So we will first check if the head pointer is none or not. If it is none, that means the list is empty. So if it is not none, that means there is an element, there is a node in the list. And if it is none, then it is very simple. We just point the head to this newly created node. And if it is not empty, this is the second scenario out here that I explained, we will point the next value of the node to the head value, to the head pointer. So the next of this will point to the head, and then we will reassign the head to point to this node, to the newly created node. So we will do self.head is equal to node. Now we will also implement a functionality to insert an element at the end of the list. So how can we do this? So let us define a function called insert end, or we can change it to insert back because it is at the back of the list. And this function will also take a node as a parameter. So we will again check if the list is empty or not. So if self.head is not none, that means the list is not empty. And if the list is empty, this is it's the same scenario as the insert front function. So we will just point the head to this node. But if the list is not empty, so we have a list and we wish to insert a new element, let's say out here, right? So this should point to this node, and this will be null. So how can we do this? First, we will start at this node at the head. We will keep traversing till we reach this node. Then the next value of this node will point to this newly created node. That is all that we need to do. So how can we do this? We will use a while loop to do this. So first we will define a current node which is initially pointing to the head of the list. Then we loop through the list. So while current node dot next is not null, that is, we are not at the end of the list. This is the condition to check if we are at the end of the list or not. We will continue to traverse through the list. So we will do current node is equal to current node dot next. And once we reach the end of the list, we will just update the next to point to this newly created node. So let us now test these two functions. So I will just create a main function out here. And I will create 5 nodes. So I will create a node with value 12, then a node with value 13, then a node with value 14, then a node with value 15, and I will also create an instance of the linked list class. So I will just say linked list. Now I will first test the insert back functionality. So I will say insert back node 1, then insert back node 2, insert back node 3, and insert back node 4. So what will happen? I will first insert 12, and then at the back of 12, that means on this side I will have 13, 14, and 15. So let us also create a functionality to display or print the node. So I will create a function called display, which will display or print the linked list. So let us say initially we are at the head. So current node is equal to self.head, and while we are not at the end of the list, so while current node is not none, I will also add an additional check. So if current node dot next is none, so at this point I will just print the value. So print current node dot data, and I will end it with empty string. Flush is equal to true. Else I will just print the value, and I will end it with an arrow. Flush equal to true, and I will just change the line out here. So let us now test this functionality. So I have created, so I can just display the list at this point. So ll.display. So let us see if this works. So I have my terminal out here, and I will just I will just call this program, so Python demo. So I think I made a small mistake. So this should be node 4, and I can call it not defined. So line 50. So I have to save this file, sorry. And of course I also need to update the node. So current node dot next. So I see initially it was 12, then I added a new node at the back of the list, 13, then 14 and 15. Now we will look at another functionality to insert a node in between the list. So I will create a new functionality, insert, which will take the node as an input parameter and also the position where we wish to insert the node. So let us say this is position 1, this is position 2, this is position 3, and this is position 4, and I wish to insert the node at position 3. So I want to insert something out here. So this should point to this, and the next of the newly created node should point to 14, something like this. So how can we do this? So let us explore. First I will again check if the list is empty or not. So I will do if self.head is not none, that means the list is not empty, else that is the list is empty. If the list is empty, I will just print list is empty, and I will call the insert front functionality, the one that we had already created out here. So insert front, and we pass in the node. Now if the list is not empty, we first keep a counter. So initially we are at the very first position, and we will also keep track of the current nodes. The current node is initially at self.head, pointing to the head of the list, and now we will run a while loop. So while current node is not none, that is we are not at the end of the list, if current counter is equal to index, or the position where we wish to insert the node, -1, I will assign the next pointer of the newly created node to the current node's next. And the current node's next will point to this node, to the newly created node, and we can move step ahead. So current node is equal to current node dot next, and we will also increment the counter. So current counter equal to 1. Now we will try to test this function. So let us now create another node. So node 5 with the value 1, and we will insert this at the front of the node. So I will do insert front node 5, and I will display this or print the list. So let us see what we get. So I will just clear the terminal and run the program again. So initially I had this, and now I have inserted 1 at the front of the list. Now I will also create another node. 6 is node 2, and I wish to insert this node at the second position, and I will display. So what do we get? So the node with value 2 is at the second position now, and this will point to 12, and then this remains the same. Now we will also add a functionality to search for a value in the node. So how can we implement this? So I will define a function called search, which will take in a value as a parameter, and I wish to find a node with this value. So I will first have a counter which is initially set to 1, and I also have a current node pointing to the head of the list. Then while I will traverse to the list, so while current node is not none, that is the list is not empty, if current node dot data is equal to the value that we wish to search, we can just print a statement, node with value found at location and the index value. So I can just do value and the counter, and I can increment, or I can move ahead in the list. So current node is equal to current node dot next, and so and I increment the counter. So counter is equal to 1. And if I reach the end of the list, that means the node was not found. So node with value not found. So let us test this functionality. So we can search for the node. So ll.search 12, ll.search 1, and ll.search, let's say 15. And so I will test it again. So I think I made a small mistake, so let me check. And of course, if I found the node, I can just return, so I don't have to continue with the loop. So I will again clear the screen and test it. So I have 3 nodes that I wish to search: 12, 1, 15. So 12 was found at position 3. So 1, 2, 3. 1 is at position 1, and 15 is at 1, 2, 3, 4, 5, 6 at position 6. Now we will also add a functionality to delete a node. So I will define a new function called delete. And this will take in a value. So I wish to delete a node with a specific value. So we need to search for this node first, and then we can delete it. So first we will again check if the list is empty or not. So if the list is empty, I will just print linked list is empty, and I will return, because then I don't need to search for the node. Now if the list is not empty, first we will check if the node that we wish to find is the head of the list. So I can do if self.head.data is equal to the value, then I will declare a variable delete is self.head. Self.head will point to self.head.next, and I can delete the node, and I can then return. So let's say I wish to delete this node, and this is the first node. So I will first declare this as node to delete, and then the head will point to the current heads next. So self.head is equal to self.head.next. So head will be now at this position, and then we can just delete this node. Now if the node is not the head, this is the last scenario. So how can we delete a node which is not a head? First we will declare a variable called current node, which will point to the head. Now while current node is not none, that is, we have not reached the tail of the list, if current node dot next dot data is equal to value, so we have found the node. If we wish to delete, we create a temp node pointing to the next of the current node, and the current node's next is temp node's next, and we can delete the temp node. and return. If at this stage also we have not found the node, we can just say sorry, and of course we need to update the current node. So current node dot next. So what are we trying to do? Let us say we wish to delete this node. So we call this node temp node. When we are at this position, we will then point the next of this node to the next of the temp node. So current node dot next is equal to temp node. So we will have something like this, and then we can delete the temp node. So let us test this functionality. So I can call delete 15, delete 1. I will also display the node out here, the list out here, and I will also display the list after deleting 1. So let us see what we get. So we after this position, after we searched for the nodes, I am trying to delete node 15. So we had this list, and we are deleting the tail of the list, so the very last element of the list. And out here you see we get 1, 2, 12, 13, 14, and the list, this node is deleted. Now when we are at this stage, I wish to remove the very first node. So once we do this, we get the following result: 2, 12, 13, 14. So this was all about linked list. We learned some important concepts like inserting a node in the list, deleting a node, traversing a node, traversing a list, etc. So as we see, inserting a node at the very beginning of the list is a constant time operation, whereas searching for a value in worst case scenario is O of n time complexity. So depending on the situation, there are some advantages of using a linked list over an array, but there are also some disadvantages. So whenever you have a problem, you should think about the exact problem you are trying to solve, the computational complexity, the time complexity, and then you should choose a data structure. I hope you found this video informative, and in the next videos we will learn about other important data structures. Thank you.